In this video, we're going to talk about integral test to see whether the infinite series converges or diverges. Let f be a function that is continuous, positive, and non-increasing on the interval from 1 to infinity. So in order to use the integral test, you need to check three conditions. First, function f has to be continuous, positive, and non-increasing. And let a of k equals f of k for all positive k. Then, if the improper integral from 1 to infinity of f of x dx converges, then we can conclude the series, the infinite series, converges. If the improper integral from 1 to infinity of f of x dx diverges, then the series diverges. And we'll look at some examples when we can apply integral test. Let's see whether this infinite series converges or diverges. First, in order to apply integral test, we got to make sure that f of x equals 1 over x radical x, and see if this, you could take the antiderivative of this. And we can. So what we need to do is we need to check the conditions. First, is it continuous from 1 to infinity? It is. It is continuous. And it's positive. Now what about non-increasing? Well, if you rewrite this becomes 1 over x to the 3 over 2, which is the same thing as x to the negative 3 over 2. And let's find the derivative. And when you find the derivative, you end up getting negative 3 over 2x to the 5 over 2. So from 1 to infinity, first derivative is always going to be negative, which means that f of x will be always decreasing since the first derivative is negative. So this satisfies three conditions to apply integral test. So now, if the improper integral from 1 to infinity of 1 over x to the 3 over 2 dx, if this converges, then we can conclude that this series also converges. If this diverges, then we can conclude that this infinite series diverges by the integral test. So let's evaluate this improper integral. This is the same thing as integral from 1 to infinity x to the negative 3 over 2 dx. And this is the same thing as limit as b goes to infinity of, let's find the antiderivative, you get x to the negative 1/2 divided by negative 1/2, which is negative 2, from 1 to b. So you get limit as b goes to infinity. That's going to be negative 2 over radical b plus 2 over radical 1. So what happens as b goes to infinity? That will go to 0. So it's going to be 0 plus 2, which is 2. So therefore, this improper integral converges. So what can we say about this infinite series? It converges. Now be careful. This does not mean that the sum of this infinite series is 2. That's a common mistake. This means that when you find the area underneath the curve of this function from 1 to infinity is 2. Not the sum. Sum of this infinite series is not 2. So be careful with that. However, we do know that since this converges, the series also converges. Now let's see whether this infinite series converges or diverges. In order to apply integral test, we have to see whether f of x equals 4 over x squared plus 1 satisfy three conditions. First, is it continuous from 1 to infinity? It is. You could plug in any value from 1 to infinity and you'll get the y value. Second, is it positive? It is. When you plug in values from 1 to infinity, you will get a positive numbers. Now, finally, third, is this a non-increasing function? Well, the good way to see is find the derivative of that. When you find the first derivative, this is what you get. And notice, when you from 1 to infinity, this first derivative is always going to be negative. Therefore, we can conclude that f of x is always decreasing. So f of x satisfies three conditions. So now we could apply integral test because you are able to find the integral of this function. So now if this improper integral converges, then this series will converge. If this diverges, then this series will also diverge. So let's try to evaluate this improper integral. So this is the same thing as limit as b goes to infinity for an integral from 1 to infinity dx over x squared plus 1. And you know the integral of this is arctangent of x. So you get limit as b goes to infinity for arctangent of x from 1 to b. And you get limit as b goes to infinity 4 times quantity arctangent of b minus arctangent of 1. So what is that? What happens as arctangent goes to infinity? You're approaching pi over 2. So you get 4 times quantity pi over 2 minus, what is arctangent of 1? That's pi over 4. Because tangent of pi over 4 is 1. So you end up getting 4 times pi over 4. So 4 cancels out, you get pi. So therefore we could conclude that this improper integral converges. Therefore this infinite series also converges. Now be careful again, the sum is not pi. This pi means the area underneath this curve from 1 to infinity is pi. The sum is not pi. But we know that this infinite series converges and has a finite sum, but it's not pi. Now let's see if this infinite series converges or diverges. So in order to apply integral test, we need to see whether f of x equals 2x over x squared plus 1 from 1 to infinity satisfy three conditions. First, this is continuous from 1 to infinity, and they're all positive. So first two conditions are satisfied. What about the third? If you take the derivative of that, you will get this. This is a good time for you to practice the taking the derivative. So make sure when you take the derivative of that, you get this. And notice, from 1 to infinity, this is always going to be negative. Because the denominator is always positive. And when you plug in the number that are greater than 1, the numerator will be negative. So this means that first derivative will be negative from 1 to infinity. Therefore, f of x will always be decreasing. So all three conditions are satisfied. So now we need to evaluate this improper integral and see what happens, whether it converges or diverges. In order to take the antiderivative or integral of this, we got to do u sub. Let u equal to x squared plus 1. Therefore, du is 2x dx. So the integral, using the u sub, this becomes du over u. And what is the antiderivative of that? It becomes natural log of absolute value of u plus c. So this becomes natural log of absolute value of x squared plus 1 plus c. Now notice though, this is definite, so we don't need c because we have a lower and upper limit. So when you take the integral of that, you'll get limit as b goes to infinity of natural log of absolute value of x squared plus 1 from 1 to b. So this becomes limit as b goes to infinity natural log of absolute value of b squared plus 1 minus natural log of absolute value of 2. So what happens as b goes to infinity? As b goes to infinity, this goes to infinity. And what is natural log of infinity? Well, it approaches infinity. So it will be infinity minus natural log of 2. And infinity minus a constant is still infinity. So therefore, we conclude that this improper integral diverges. Therefore, this infinite series also diverges by integral test.